curious, how many devices are deployed but not in use at the end of each month? So maybe it's deployed, but it went into maintenance. And so what we're curious is, when am I deployed but not in use? And what I'll do in order to constitute that data or constitute this analysis, I'm going to actually create just some dependent columns here. And now there's a good number of binary signal analysis tricks going on here. And so I'll share with you what those are. And just like before, I'll just print out the dot head so you can see at least the first 5 rows. So what I've done is I've taken my deployed column and I said, you know what? Wherever we see the state is deployed, that is when I know that this device is going to be deployed forthwith until it gets decommissioned. Now, being decommissioned is always going to be the absolute last entry. And so I think I can ignore that for now. I'll actually factor that signal into my in-use signal. But what I can do after I've identified which rows have a deploy, I can group by my device, and then I can take a cumulative sum. Now the cumulative sum, I'm treating it kind of like a forward fill here. You can see that before I had a Boolean column. And so I'm taking that cumulative sum because I want to carry forward any signal where deployed is true and carry that forward through the rest of my time series for a given device. And that's why I'm grouping on the device here. Then I want to calculate my in-use signal. Now this is a little bit trickier. And so what I'm doing here, I'm doing much of the same thing that we saw before. I'm checking where a state is either in use, or if it's in maintenance, or if it's been decommissioned. Now I'm going to assign these very different values. And the reason being is that if a device is in use, this means my binary, my in-use signal, that is in the up position, or it's on, as we would say. If I then enter a maintenance period or a decommission period, I'm going to update that signal by subtracting 1 away. And what this does is when I fill my NAs and I perform that cumulative sum, this is actually going to carry that in-use signal forward as far possible into the future. And so I'll print out just a couple more heads so we can see exactly what that looks like. I now have rows that tell me, or I now have a column that tells me if the device is currently in use and if it's currently deployed. And right now, this is a good example. I keep flip-flopping between in-use and maintenance, in-use and maintenance. The reason I perform that cumulative sum on the in-use is if I have some other state in between an in-use and a maintenance, well, that device is likely still in use. And if that state actually means something else, well, I can just update my mapping that I've supplied here. 1 being we are currently in use, and -1 being we are not currently in use. Now, you can look at these time series, and I could plot these as a Gantt chart if I wanted, or a p-color mesh specifically from Matplotlib. But we're more interested in the analysis here that we have at hand. And so what's really neat about this analysis, I'll go ahead and I'm going to just make one assertion about my data. Just want to perform a validity check because I know that each device should only be deployed once. And so if I ever see a device that's deployed more than once, I know there's either something going on with my data or something going along with my analysis code. So let's actually get into the pandas level analysis here. Now that I have my 2 binary signals, my 2 independent columns that are tracking when a device has been deployed, or if a device is currently deployed, and if a device is currently in use, I simply want to resample my data here. And so instead of using the pandas.resample, which does make the assumption that my date times are the sole entity in my index, I'm going to use a pandas grouper. This is going to have just a slightly different behavior than a resample because I'm going to create non-overlapping windows every 1 month. So I'm grouping on my device. So for every device, I'm going to break the time series down into month-long chunks. And then I'm simply going to take the last element from that group by operation. Now, one thing that we are relying on is we are relying on the orderedness of this index. So I should actually be sorting my index here because I have, or I should be, sorting on my values actually in this case, because I do have, my groups and then my time series as my actual values. I know actually in advance that these values are already sorted, so we can go ahead and leave the data as is. And actually, let's verify that. I would never want to make a blanket assumption and be wrong about the state of my data. And so let's see, we have our device and then we have our time, and it does look like this is increasing within our device, which is excellent, and so on and so forth. I could do a quick sort index if I wanted pandas to already to sort these things for me. Of course, I could ask pandas, right, is my index currently sorted? And it can give me that information as well. That's is monotonic. And that should be my index. And so pandas will use a lot. They actually updated this. So I would have to get the index level values out, but I am convinced that these are sorted. And if I wasn't, a quick df.sort index here gives us our answer. Now, what this is doing, I've simply just performed a grouped operation, every device just grabbing the last data point for a given month. And because I'm grabbing the last data point, I am fairly confident that this is the actual state that my device was in at the end of this month. And you can see I'm not limited to performing this analysis on every month. I could do it every 7 day or every week instead. And you can see here, just grabbing the last known state of your signal, it gives you a lot of flexibility in the analysis that you want to conduct here. Now, the next thing that I want to do is I'm going to want to filter my data. So I'm going to ask my current data set, given these months that we've examined, right, which devices are currently deployed, and then which devices are currently not in use here. So we'll assign a new dependent column to track that information as well. And you can see here for the device 29NY, we are going to, of course, say that this is not currently abiding by our rules. We want to find out when is something deployed and not in use. And so that's why we end up getting a true for the second row, because we have a pattern of 1 and then 0 in the deployed and in use columns. So those are the patterns that we're looking out for. I could, of course, perform a filtering operation on these if I wanted. But what I'm more interested in, I actually want to perform a count, right, per month. How many different devices am I seeing in use for a given month? Now, what we've done here with this analysis is because we are tracking when these things are actually decommissioned, that means they're going to be removed from future analyses. So what this would look like is if I decommission this device here, CKRP, well, I should not have a state for CKRP in May. It's been decommissioned by the end of April. Therefore, I should never see this device again in the future. And so what I can actually do here, I'll do a quick swap on my index. So you saw I did a swap level with a sort values. And so what this is doing, this makes it really obvious what I'm looking at here. I'm looking at every single month, how many of these devices are active for this given month. And now you can really visualize that this is just going to be a group by operation on my time, and it's going to be a summation of my signal, because we want to count how many trues we have here. Now I could do something like a dot value counts as well, and this gives me this will give me the total of how many devices are active and which states they're in. So in this case, I have 3 devices, but none of them meet my criteria, and so on and so forth. So a lot of different ways that you could perform this analysis here in pandas, but note the heavy use of the index in order to perform my alignment and my aligned operations. But what does this look like in polars? Now with polars, we have a little bit different of the assumptions that we make. So I'll start from the top. We're going to read this Parquet file, and we just need to fix that. That should be signal, and I'll just print out my DF here. Excellent. And I will move this outside of my config. And we just need to pass. Okay, so now that we have our columns here, we can see our data is much the same. Now, one thing that I do want to make very careful and pay very careful attention to is the actual sortedness of my values here. I don't have an index to rely on. I can't simply set my index for device and time and then sort on my index. So I do need to make sure that I'm sorting at least by a column that I know should be ordered so that Polars 1 can make use of this information or can actually work with this information the way that I'm expecting it will. But 2, by having a sorted column, Polars can make a lot of the same fast track operations that pandas will if you have a sorted index, like you saw me perform with that is monotonic check. With the pandas index, what ends up happening if you perform a slice operation in pandas, whenever you see there's just going to be some pseudocode. If you see pandas, a df.lock, well, this can perform a number of different things. If I say df.lock, let's say row K and beyond, if this index is monotonic, all pandas has to do is find the position of K and then return the rest of the array here, so it can perform a nice slice for me. If I say something like index.lock, maybe some value here, lambda series, where the series is greater than a value 10, this is going to return non-contiguous view because I'm applying a Boolean filter. But what ends up happening is you can have a fast path embedded if you want to perform a slicing operation and you know that your index is in fact sorted. Well, you can simply on your own find the position of 10, like argq, right, the position of 10 forward. This will actually give you a contiguous slice back and be much more memory efficient in terms of pandas. But what pandas needs to know is this index sorted or not before it can actually make those different assumptions. In contrast, Polars will actually know if each of its columns is in a sorted state. And if it is in that sorted state, it can apply fast track or fast path operations for you to work with. Now, this happens all behind the scenes, and all I'm doing is I'm paying for a sort up front, and that's it. So I'll go ahead and I'll sort my data on the time column, and then you can see my with columns method here. This is very similar, but not the same as a .assign in pandas. And what we're doing here, what's actually quite different, and I do actually quite like here, you can see I'm passing in my columns. I'm seeing where is the state column equal to deployed, and then I'm casting that to an integer type because it comes out as a Boolean type. Now, I believe I could work with this as a Boolean type as well. Then I'm going to take the cumulative sum, and instead of performing a group by device and then a cum sum, I perform a windowed operation. I'm using this over method here on my expression. What this lets Polars do, it lets Polars calculate these on a window. This is exactly going to be pretty much the exact same as a pandas group by transform, but we are ditching the .transform syntax for just something that's a little bit more familiar if you write a lot of SQL or use window functions in some more common database tools. So that's what my deployed column looks like. You can see it's pretty much the exact same as what we saw with my previous entity or my previous pandas analysis. And if I go ahead and I sort this on device and time, we can actually see, right, that this column comes out very, very similar to what we saw with pandas. Thanks for watching. If you enjoyed this video, give it a like, hit subscribe, and check out the recommended video on the screen. See you in the next one.